Hi, my name is Dina Adanya, and today I'll be giving a brief overview on our IDP project. Before that, allow me to introduce our group, which consists of 5 members: me, Yamuna, Amefitri, Magdi, and Fakro. Moving on, our team was instructed to create a pipeline for the production of sulfuric acid. In this project, we will be dividing it into 2 segments, one for principle of chemical engineering and another for fluid mechanics. By utilizing the knowledge from these 2 subjects, we were able to successfully create a plant based on the contact process to produce sulfuric acid.
Hi, I'm Yamuna Anandampan Kartikesu with student ID number 22001710 from Chemical Engineering. The course of Principle of Chemical Engineering introduced fundamental technical knowledge prior to chemical engineering sector. This technical knowledge will be applied in determining the accurate parameters such as molar mass flow rate, temperature, and pressure in producing desired chemical product via multiple process units. The purpose of this project is to put information we've learned this semester in Principle of Chemical Engineering to use in real-world setting for the production of sulfuric acid. Sulfuric acid is a mineral acid made up of sulfur, oxygen, and hydrogen. Sulfuric acid can be produced by contact process, which consists of 3 main parts: make sulfur dioxide, convert sulfur dioxide into sulfur trioxide, and convert sulfur trioxide into concentrated sulfuric acid. For the process flow diagram for PCE, we will be having several process units. Sulfur dioxide from diarrhea will flow into burner, cooler, washing tower, drying tower, arsenic purifier, and preheater. After it reaches catalytic converter, sulfur dioxide becomes sulfur trioxide where it flows into absorption tower and becomes sulfuric acid. From there, it will flow into dilution tank and storage tank. I'll be explaining about some of the unit operation involved in production of sulfuric acid. The first one would be burner, where liquid sulfur and dry air are fed into a burner and burned at 1150 degrees Celsius. Next one would be washing tower, where impure sulfur dioxide gas is passed through washing tower as a filtration process by spraying water. Besides that, the next unit operation would be preheater, where pure sulfur dioxide gas and excess dry air is heated to 450 degrees Celsius to prepare for subsequent unit operation. Next would be absorption tower, where sulfur trioxide gas is passed through absorption tower and is absorbed by concentrated sulfuric acid to initiate a chemical reaction. Lastly, storage tank, where final product of sulfuric acid is flowed into the storage tank to be stored.
Hello, my name is Amefitri, ID 2200Y77, and I'll be explaining about mass balance and energy balance in reactive and non-reactive system in PCE. For non-reactive system, the unit used is the dry unit. It is used to dissociate water from SO2 and MHC. Another stream with concentrated H2SO4 will enter into the unit. So the first table shows the molar flow rate of input and output. While assuming the efficiency is 100%, we can see that water did not exist in stream F2. As for the second table, is the mole fraction of the process. It is basically the ratio of mole substance to the total mole of all substances. The third table is the mass balance table. So for energy balance, since it is a non-reactive system, it is basically entropy in equal to entropy out. Setting the reference set of temperature equal to 100 Celsius, we will get the value of total energy. As for a non-reactive system, it is a contact system where SO2 reacted with hot air to produce SO3 with the assist of a catalyst. So for mass balance, we assume that all SO2 is converted to SO3. So you can see there are no SO2 in the outlet. There are still oxygen in the outlet because there are excess reactants. There are not enough SO2 to react with. We can obtain the molar fraction and mass balance the same method from non-reactive system according to the first table. For energy balance, heat of reaction is involved due to the reaction that happened. SO2 reacted with air to form SO3. So the total of enthalpy is not just enthalpy in equal to enthalpy out, but now it involves heat of formation. So we sum all of that and we will get the total of energy exerted equal to negative 5813.47 kilojoules per second. That's all from the team.
Hi, my name is Muhammad Fakru bin Nokman, student ID 210000268. Introduction in fluid mechanics. The production of sulfuric acid is a pivotal commercial process with massive ranging application, ranging from the manufacturing of fertilizer and detergents to the process of metal and chemical substances. Fluid mechanics as a cornerstone of the challenge play an essential role in shaping of overall performance and reliability of the production technique, from the preliminary copying of feedstock to very large synthesis of sulfuric acid. Fluid dynamics govern the flow of gases and drain through complex network of pipes, vessels, and reactor. As you can see from the pipe diagram, the type of the pipe that we use is stainless steel. The diameter of the pipe is 0.47 meter and is fitting 90 degrees standard elbow. The valve is globe valve and the length of the pipe is 5 to 10 meters. Assumption: flow rate is steady, resistance due to enlargement Ke equal to 1, resistance due to contraction Kc equal to 0.5, the delta V equal to 0.
Hello everyone, my name is Muhammad Magdi, student ID 21000093, and today I'll be presenting for you the calculation for fluid mechanics and the storage tank. Without further ado, let's start. Okay, so we have three pipes, pipe S7, S8 and S10. In order to calculate the pressure drop, we have to find the velocity, the Reynolds number, friction loss, friction factor, and then calculate the pressure drop by adding the pressure drop of each pipe and then get the total pressure drop. So let's start. So we know that the formula for pressure is P is equal to rho RT and R is equal to RU by molecular weight. RU is equal to 8.314, that's the ideal gas constant. So we can rearrange the formula to get the densities for each of the components, SO2, O2 and N2. After calculating the densities for the components SO2, O2 and N2, we add them together to get the average density. Then we calculate the velocity. The velocity can be calculated through the formula of mass flow rate. Q is equal to AV. We can rearrange the formula to get the value of the V. But first we have to convert the mass flow rate from kg per second to meter per second and then get the velocity. After getting the velocity, we can calculate the Reynolds number by the formula RE is equal to rho Vd by viscosity. After calculating the Reynolds number, that's equal to 1.34 multiplied 10 to the power of 8, which is turbulent flow because it's more than 4,000. After getting the Reynolds number, we can calculate the friction factor. The friction factor can be either calculated by using the equation or by using Moody's diagram. After getting the value of the friction factor, that's equal to 2 multiplied 10 to the power of -3, we can calculate the total friction loss. The total friction loss can be calculated using the formula of K pipe plus K fittings plus K valves plus Kc plus Ke. The K pipe is equal to 4FL by D. After getting the values for the K fittings and the K valves and assuming that Kc and Ke is equal to 0.5 and 1, we can get the value of the total friction loss, which is equal to 1.44 multiplied 10 to the power of 9. After calculating the total friction loss, we can finally calculate the pressure drop for pipe S7 by rearranging the Bernoulli equation to delta P is equal to minus F by G to the power of rho G. And then we can calculate the value of the pressure drop, which is equal to minus 7.78 multiplied 10 to the power of 8. And then we repeat the steps for pipe S8 and S10, and then we calculate the total pressure drop. After calculating the pressure drop in pipe S7, S8 and S9, we can finally calculate the total pressure drop in all pipes by adding them together, and it's equal to minus 1.44 multiplied 10 to the power of 9. So moving on to the next slide, which is the storage tank. The storage tank dimension and capacity depends on various factors such as the production rate, delivery frequency, and the amount of sulfuric acid consumed or sold. The storage tank we used here is HDPE, made of high-density polyethylene with diameter of 60 meters and height of 20 meters. The capacity of the storage tank is 56,548.67 meter cube, which is sufficient for the amount of sulfuric acid produced. Should be maintained under temperature of 25 degrees Celsius and pressure of 101 kPa. The production rate for sulfuric acid per second is 0.546 meter cube, and the production rate per day is 47,174.4 meter cube. Thank you very much for listening to me. Moving forward to Dina, my groupmate, for the conclusion.
In conclusion, it is clear that the application of both principle of chemical engineering and fluid mechanics play a significant role in creating an energy-effective contact process plant to produce high-quality sulfuric acid for future industrial use. For principle of chemical engineering, we use the concept of mass balance and energy balance, which relates directly to the concepts in fluid mechanics, which are conservation of mass, first and second law of thermodynamics. Both subjects have helped our team analyze the amount of product to be produced, how it will be transferred throughout the pipelines, and the criteria needed for it to be stored. With that being said, this was our project to produce sulfuric acid. Thank you.